Welcome to All This Math. This is Professor Parker, and today I want to talk about the slope-intercept form of an equation. But I want to talk about it in a different way though, right? Because I kind of want to talk about how this is actually useful and how a lot of us, unbeknownst to us, we use it all the time and don't even realize it. We don't even dig how we're actually using the slope-intercept form of an equation, even if you just try to calculate your weekly paycheck or your bi-weekly paycheck, or if you need to stack some money and save some money up and you work a job and you have an hourly wage and you just want to know, okay, well, how many hours do I have to work or how many hours do I have to put in order to stack that amount of money in order to acquire that thing that I want to buy or go on that trip that I want to take or make that investment that I want to make. We use it all the time. We just might not call it the slope-intercept form of an equation, but for real, we're using it. All right. And this is how we would use it, right? So let's say, for the sake of simplicity, we're going to talk about a typical person that works a job. They make an hourly wage. Their hourly wage is $10 an hour. All right. So $10 would be their rate, right? That's their pay rate, right? So when we deal with our pay rate, that's M, right? Our pay rate. Now, how many hours do you work? Because a lot of us know, okay, if I want to calculate what my paycheck should be or what I expect it to be, I take my salary, not my salary, I take my hourly wage and I multiply it by the number of hours that I worked, right? So let's say, that's your number of hours that you work, right? We know this, it's pretty basic stuff, pretty fundamental, right? So let's say they work, well, let me write my information down. So my M is $10. My X is the number of hours I work. Let's say in this particular week, this person works 40 hours a week, right? Or 40 hours that week. All right, now Y is the paycheck. That's what Y is. Y is the paycheck, all right? So Y is how much money that should be in that check. And this is very important to do because we want to make sure that our calculations match up with our employer's calculations. And we want to make sure that our employer is not shortchanging us, right? Whether through some type of honest mistake, an honest error in the payroll department, or whether it's through somebody at that employer trying to rob us without us knowing it, right? Either way, we want to make sure our money is straight, okay? And we use the slope-intercept form to do that, right? Even if you don't realize that you're using the slope-intercept form to do it, you are doing it, right? So we go over here and I write Y equals M, which is 10, times X, which is 40, because in that particular week, I worked 40 hours. Now you might be wondering, well, what about the B though? The B is what's called the Y-intercept. That's your starting money, right? That's the money you start out with, right? So if you start out with, let's say before you even came to work that week or started working that week, let's say that the company already provides you with $50, right? Whether you show up to work or not, or the company already spots you $100 or $200. You'll see this used in a lot of situations and scenarios when, let's say a person works a sales job, right? Because in a lot of sales jobs, well, some sales jobs are just straight commission, right? If you don't sell, you don't eat, right? If you don't sell nothing, your paycheck is going to be zero, right? But there's some sales jobs where the employer tries to subsidize you a little bit, right? Give you a little bit of cushion, right? So you'll have a base salary. And then on top of that, this will be your commission, right? So the amount you make per sale would be M, and the amount of sales you make would be X. You see this in the restaurant industry a lot, right? Wait staff, waitresses, waiters, right? So what happens is they might make, a certain amount of money per hour, right? Like $1 and some change, $2 and some change, $3 and some change. But then their real money comes from their tips. All right. So the tips might be calculated within this part of the equation, MX, the MX part, right? But now back to this. So here we don't have a B, right? Because we just only are dealing with a person that has a $10 per hour job and they work a certain amount of hours. So in this case, B is $0, right? So if you want to include that in the equation, it would be plus 0. It's plus nothing. And nothing is just that. So we just cancel that out. But then if we want to calculate what the paycheck would be, it would just be 10 times 40, which is $400. right? Now we just used y equals mx plus b, right? We just used it. It's just a format that enables us to do calculations, and with those calculations, we can plan for the future, or we can verify information, okay? So now y is equal to $400. Now what if we are trying to calculate more hours than 40 hours? What if, I don't know, we're doing 2 weeks and we had to take some time off that week, and let's say X wasn't 40 no more, but let's say it's 75, because now we're dealing with a 2-week period, and we're saying, okay, in the first week we worked 40 hours, and then the next week we worked 35 hours, so you add the 40 plus the 35, which gives you 75. So now we're still making $10 an hour. Multiply that by 75. B is still 0, so we don't got to worry about that. So y is equal to $750. So in that period of time, we're making $750. Okay? Another way we could use the slope-intercept form, and there are a lot of ways we could use it, but I'm going to just go into a couple of them for right now, right? Another way we could use it, let's say we have a goal, we have a financial goal. We need to stack a certain amount of money, okay? Whether it's to make an investment, whether it's to take a trip, whether it's to purchase some things that you need or your children needs or somebody in your family needs, we can also use the slope-intercept form. So let's say in that situation, let's say I need to make $1,200, right? So if I need to make $1,200, I'm gonna use this formula, except the 1,200 is the y. My y value is that $1,200 that I need to make, right? Now, this person, let's say this person, hypothetically, they still make $10 an hour, right? So my M is still 10 because that's my pay rate, okay? But I need to know how long that's going to take me. How many hours am I going to have to work to make that $1,200? So this X right here, this is what you don't know. So now this is what we're going to figure out. Notice in these first examples, we knew M and X and we figured out Y, right? Well, actually, we knew M, X, and B. We had to figure out Y. Now we know what Y and M and B is. Now we're going to figure out X. See, that's like part of the beauty of algebra. Like when you know some things, you can use the things you do know to figure out the things you don't know, right? And again, these are things that we do almost innately and instinctively already, but we just don't know that we're doing algebra when we do it. And what I want to say is, I want people to start thinking like more mathematically, like, yo, okay, yeah, I'm doing algebra. So algebra is really not that intimidating. It's not really useless like that, because I actually do use it. I just didn't know I was using it, right? So now, if you got your Y is 1,200, your M is still $10, and X, we don't know what X is, all right? So basically now we have an equation where we need to solve for X. And the way we solve for X is by isolating X by itself, all right? So we do that by doing division. So we divide by 10 on the right side, and we divide by 10 on the left side, all right? So 1,200 divided by 10 is going to be 120, right? And the reason that we divide is because in order to eliminate something in an equation, you have to do the opposite operation that it was already involved in. 10x means 10 times x. Times means multiplication. So the opposite of multiplication is division. So we divide by 10 over here, and whatever you do in an equation, whatever you do on one side of the equation, you must also do on the other side of the equation. That keeps the equation balanced. So now we have 1,200 divided by 10, which is 120 divided by 1, really. So that's 120. So that tells us that in order to put together or accumulate $1,200 at $10 an hour, you need to work 120 hours. All right, 120 hours. Now, that 120 hours, then you can break it down, figure out how you got to break that down. You figure out, okay, well, if I can work 40 hours a week, then you figure out how many weeks do I got to work. So how long is it going to take me to accumulate this $1,200? You see, so like when we use algebra and we become more comfortable with algebra, we can start doing some decision making. We can start planning for the future. We don't just got to leave everything to chance, right? We can start problem solving, because what we've done here is solved a problem. If this person right here has a problem that they have to solve, this person's problem is that they need to accumulate $1,200, and they need to know how long it's going to take them to accumulate the $1,200. So we solve the problem by using algebra, and now the problem is solved. We figured out what we need to do. Now it's just an issue of going out and doing it, right? But the first step is to be able to plan. How am I going to do that? All right, I need to work 120 hours, okay? And then we can get into the conversation about, well, hey, you know what? To make $1,200, I got to work a whole 3 weeks. Man. So then we can start thinking critically, like, what if this person, wants to buy some designer sneaks that cost $1,200? And then they can ask themselves the question and say, dang, is one pair of sneaks really worth 3 hours of my life? 3 hours, or not 3 hours, 3 weeks. 3 weeks of my life. I work 3 weeks at 40 hours a week just to wear one pair of sneaks. Like, am I really going to get the amount of enjoyment and the amount of appreciation that's going to be equal to the amount of effort and time and energy, blood, sweat, and tears, whatever, that I got to dedicate toward working at this job for 3 whole weeks? See, these are the conversations that we got to start having with ourselves, and we got to start having with our children. We got to start thinking of money in a different way. We got to start thinking about the value of time. Like, what is your time worth? So we start thinking about what our time is worth, and the math enables you to get into that conversation and be able to see it on paper. Like, yo, all right, you want to buy something that costs $1,200? That's going to take 120 hours of work. And 120 hours of work at $10 an hour, So then, you might say, well, no, it's not worth 3 weeks of my life, but maybe it's worth 1 week of my life. So you say, okay, well, if it's worth 1 week of your life, then we got to figure out how you can get a job where, drop my marker. It's cool, I got another one. So where you can make more in 1 hour, right? So if this number, this 10 right here, if this number goes up, then that's going to decrease this number. You see? So you start playing with the numbers, right? Start playing with the numbers and you start getting somewhere. But anyway, I just wanted to get into this. And actually, I want to shout out my former student that sent me or tagged me in a Facebook post where somebody made a joke. It's a typical joke that you see all the time. Somebody said, oh, another day in my life where I didn't have to use y equals mx+b. And I get it. There's a lot of frustration that a lot of people have around mathematics. And I take ownership of that because a lot of math teachers, myself included, we don't do a good enough job showing the real world application of a lot of the formulas that we throw at our students. We throw formulas at our students all the time. We show them equations. We do a lot of problems, but we don't get into the word problems. See, the word problems are the real life applications. But the problem with that is the word problems become intimidating to a lot of people, right? Some teachers are intimidated by word problems as well. That's why they don't teach them, right? There were times in my career when I used to shy away from teaching the word problems. So I'm like, I don't know, and then I didn't know how the students would react. And I would get the negative feedback from the students as well. So, but nowadays I go hard with the word problems because word problems is what it's all about, because the word problems really show you the real world applications. And then the students won't be sitting in class frustrated, like, when am I going to use this stuff? What's the purpose of knowing this? How can this help my life? When we get into the word problems, you see how it can help your life, right? We just talked about working a job, money, how much time of your life you have to dedicate toward making a certain amount of money. These are all real world issues and real life issues that everybody has to deal with. And we can use algebra to address those. All right. So that's all I wanted to talk about. And I kind of wanted to take a different approach today. This isn't really like a more typical math problem, but just, I wanted to put a concept out there and just allow whoever's watching this video to just, think about some of these types of things. All right. So again, thank you for tuning in. Please like the video. Please subscribe to the page. Please tell more people to like and subscribe to the page. And always remember that there's all this math all around you.